In this tutorial, we'll see the functions available for those requiring to model objects made by sheet metal bending. Users are not forced to follow a single predefined approach, but depending on the specific project, they are free to use the technique they wish. Now, let's go on with this task, helping to get an idea on how to use the sheet metal commands. Our goal is creating a sheet metal housing for the engine we loaded. We activate the panel with the arrows managing the predefined use, and first of all, let's say we have some parameters managing the different sheet metal features called global parameters. The sheet metal category of the entity properties provides a series of options controlling, in this case, the calculation of the allowance to take into account the shrinkage and elongation undergone by the material we use, either by the K factor or picking up from a set of tables specifying the values of shrinkage as a function of thickness, bend radius, bend angle. Let's analyze all the other parameters belonging to the sheet metal commands. We can see bend reliefs, corner reliefs, flange corner, okay, positioning, and finally rip corner. Okay, we set default for each table and end up by OK. These are the global parameters used by the first sheet metal features we are going to apply. Now, let's start from the profile at the base, from which we create a linear solid 5 mm deep and confirm. The first solid object makes up the thickness of the sheet metal we are going to build. We apply the flange command, which wants us specify an edge. We select the bottom edge, so the flange goes down, panning a little bit upwards and resetting the edge. We select the one on the top and we set length to 100 mm. OK. Let's see where global properties come into play. On this flange, an inner bend radius of 2 mm is set because it comes from the global properties options. The alignment as well comes from these properties. Anytime upon inserting a sheet metal feature we can unlock these properties. In this case, clicking on the lock, we can unlock the alignment, set to inner flange, and choose any other value, outer flange and bend, bend line. We chose outer flange and bend and confirm. Let's insert another flange on the opposite side. This time, instead of entering a value for the length, we specify that it will have to reach the point of the first flange we created. So we set for it up to point, unlock the inner bend radius, and type 4 mm. OK. Obviously, this flange will be updated accordingly to the length of the other one. Let's check, selecting the first flange and redefining the feature. If we extend its length to 120, even the flange on the other side will be updated accordingly upon rebuilding. The flange didn't require any thickness because it detected the one of the first solid object on which we hooked. It was made by a linear solid. Redefining it and typing 2 mm instead of 5, the flange thickness changes upon rebuilding. Its value is inherited from the first solid feature. OK, let's insert another flange and modify length to 15 mm on the inner flange and activate the offset, that is, a value allowing to move away from the coupling edge outside or inside to build up the flange at a specific distance with respect to the coupling edge. We set it to 6 mm and we confirm. So far we have dealt with global properties, the ones coming into an operation when we activate the feature, while local properties are those related to the feature we are going to apply. Moreover, we have the solid properties that in here reflect the global properties. We can change these values anytime. From the properties of the solid entity in sheet metal, we set 0.8 instead of 0.33 for the key factor, 1 mm for the inner bend radius, and uncheck normal side faces. OK. We notice that the bend radii of the flanges we inserted, taking into account the global properties, are updated respecting the values of the sheet metal properties associated to the solid. So the bend radius has switched from 2 to 1 mm. For the other flange, on the contrary, we had entered a local property. In fact, the bend radius was unlocked. Blocking it again, the values of the properties associated to the solid object is taken into account and we rebuild. OK. We go on inserting some flanges to see the different functions provided. On the edge on the back, the offset is set because the commands are modal, so they keep the last settings provided. We remove the offset and type 100 mm for length, block alignment, so the value of the global properties associated is taken into account, and in more options, activate orientation, that is, the possibility of managing an orientation angle for the flange, and we set 70 degrees and apply. Staying inside the command because we are going to add another flange on the edge, always with an orientation angle. This time we specify that we don't want the angle with respect to the edge face, but with respect to a line that we select on the edge of the engine. OK. We set length now to 38 mm. And let's view the engine from the side view. We set the angle to 10 degrees, not inward, but we invert it outwards, and we confirm. Little by little, we are building up our sheet metal object. Now, let's insert another flange. On the edge of the back, the orientation is set. We are asked as reference plane a line. In this case, we give an orientation line. We set the angle to 0 degrees and length not by value, but up to point, and clicking on the point and confirming, we get the final object that we can save now as SM_Carter.